Hello, and welcome to the Kentucky Valley Educational Co-op's The Holler. Today we are going to discuss how to use algebra tiles to teach different parts of algebra. And so we're going to start out with just teaching integers. Okay, so let's start out today by talking about what are these algebra tiles. Let's begin with that. And so if you're looking at algebra tiles with your kids, first of all, just let them touch them, play with them, enjoy them in a way that they can understand, because one of the things that I want them to start to see is this is considered one, or a unit. So 1, 2, 3, and then of course if we can flip them over and they're negative. So this would be positive 3. This is going to be negative 3. Now I want them to see that this is a positive x and this is a negative x. And the reason being that this is x is we know it's 1x because this fits here fine and dandy, so it makes it a 1. But when we move down through here, and they can line these up, and I talked to them about lining them up and seeing if they actually fit. So this represents x because I can't technically fit an exact number on here. It's some number. So it is 1x. It is a variable, and like I said, it's 1x because we technically cannot determine what this number is. Now, the cool thing about this is x squared. Now the reason this is x squared is if you look at it, it is 1x and 1x squared. Is that not awesome to be able to see that? Now this is great for later on when we're teaching. But start out with, okay, these are just 1, these are x, and talk about zero pairs. This is a zero pair because they cancel each other out. Positive x, negative x, cancel each other out. Now, same thing here. Let's talk about zero pairs, and we're going to teach zero pairs. So why is this? And this is so important when we're teaching integers. So important. Even when we're doing multiplication and division, this is so important to know zero pairs. So we teach zero pairs and how to zero out. And so we build 4, we build positive 4, we build negative 4. Are these zero pairs? Yes, and I can move them out. And so we keep on doing this. We build it, we continue to build it. So, and you do that with multiple numbers. So you say, okay, build 3, build negative 3, and we can zero out. You can make them do them one at a time. Like I said, this is extremely important for our students, especially those that struggle. Now the next thing, let's go in and start talking about just doing simple addition and subtraction with those. Like I said, building that zero pair is so important. Okay, so I got some problems here in the bottom, and we're just going to work through these today, and we're going to talk about how we would work through them with the students. So I've got 4 plus a negative 4. So of course, build my 4, and I'm making sure it's positive 4 because that's what that is, positive 4. And I'm going to line those up. Now I'm going to add negative 4. Now this is where that zero pair that I just talked about is so important. So here's my zero pair. Now that I've done this, can I zero out any? Of course I can. There's 1 zero pair, 2 zero pairs, 3 zero pairs, 4 zero pairs. So with addition, if I can zero pair them out, I have none left. Now, the next one, I have 6, positive 6. And I'm adding 0. If I added 0 here, this is all I have, then my answer is 6. They know that one. They've probably already built that one since the time they were in first grade. The next one, -5. plus negative 3. Now, can I zero pair any of those out? No, they're alike. They're the same type, so they just get added to this. And now I have, of course, a negative, but I have 1, 2, 3, 4, 5, 6, 7, 8. Negative, because they're all red, 8. So negative 5 plus negative 3 is negative 8. So if I got a negative and a negative, it's going to continue to be a negative. And of course, I'm adding them all together because they're alike. Now, I have negative 2 plus 5, negative 2 plus positive 5, create my positive 5. Can I zero pair any out? Absolutely. These are zero pair, these are zero pair. What do I have here? Well, they're yellow, so they're positive, and it's 3. So my answer is positive 3. Now, the kids can write the positive in front of that if they need to. That's fine. Next one, negative 5 plus negative 1. So negative 5, no, I'm sorry, negative 5 plus 1. So negative 5 plus 1. Can I zero pair out? Absolutely. And at this point, it's 1, 2, 3, 4. They're negative because they're red, so it's negative 4. Next one, positive 5 plus negative 3. Can I zero pair out? Positive and negative, positive and negative, positive and negative. They're gone away. I have 2 and they're positive. So this becomes positive 2. Now, one of the things I really want for my students is to start to see what happens with certain numbers. So we can talk about using the same numbers, or we can talk about using a just an alignment. So if it's, and we'll do that. So let's say we got 5 plus 1, 5 plus 0. We're going to do a 5 plus 2. And we're going to do 5 plus negative 1, 5 plus negative 2. And so they can see it this way and look at what's happening with the pattern. So if I've got positive 5, positive 5, that's not the straightest line you've ever seen either. And I'm adding 2. These are alike, correct? I mean, they're positives and positives, so I can just count them up. 1, 2, 3, 4, 5, 6, 7. So my answer is 7. Now I've got 5 plus 1. 5 plus 1 is 6. 5 plus 0 is 5. Now I've got 5 plus negative 1. What happens here? They're different. I have to zero pair. And now I have 4. Can we start seeing a pattern here? I've got positive 5 plus negative 2. I zero pair out. I have 3. They can start to see that this actually becomes a subtract. So we haven't said anything right now about any kind of procedure, but they're starting to see it. They will start to see that, oh, this is just like 5 subtract 1. 5 subtract 2. See how they can see that in a pattern? Well, let's talk about it this way too. So let's look at, we're going to again use 5. So if I'm doing 5 plus 2, 5 plus negative 2, negative 5 plus 2, negative 5 plus negative 2. So we've looked at all the options that are there. Now let's, again, we're going to put 5 up here. And we want them to see patterns. Because patterns is all through mathematics. So 5 plus 2 is 7. 5 plus negative 2, at this point we have to zero out. And if I zero out, I have 3, positive 3. Now if I have negative 5 plus positive 2, I take these away because I'm zero pairing out, right? And I have what left? Negative 3. At this point, I've got negative 5 plus negative 2, and I count them all together because they're alike, and I have negative 7. Now we can look at the pattern. If I had a positive and a positive, I continue to add and I have a positive. If I have a positive and a negative, I subtracted and I looked for the sign of the larger number, and I have a positive 3 in this case. If I had a negative and a positive, again, I subtracted. I looked for the sign of the bigger number, and I have a negative 3. And if I had 2 negatives, I went ahead and just added those negatives together because they're alike. So this is what we want to talk to our students about when we're doing this with addition. Let's talk about subtraction. Okay, you can talk about multiplication by doing just building both groups of 0 pairs. So I could do, in this case though, let's just talk about this. We know this is regular multiplication, as in the repeated addition, or 3 groups of 2. So I could actually do my 3 groups, and I'll do that. I'm going to do that up here on this sheet of 3 groups of 2. So I want to draw my 3 groups. And of 2. And so it's positive 2. So I'm going to put 3 groups of 2. Now after a while, your kids may not need to have these, and they can actually just put little pluses inside these groups. That's fine. So they can draw it like this. 3 groups of 2, and then they just count the positives. 1, 2, 3, 4, 5, 6. So this one is 6. Now this says I have 3 groups of negative 2. So if I do that, turning these over, what do I have? I have negative 6. Same thing. I'm going to draw it out. Negative, 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 negative. Oh, I didn't need this group. It's going to be negative 6. Now, the next one. This says here, and I could do this. I could do groups, and it would say I'm going to remove 3 groups of positive 2. That's what it would say. Because I can't have a negative group. So I'm going to remove 3 groups of positive 2. This is where I said you could get into building the sets, and there would be positive and negatives in this case, just like this right here. So I'm building 0 pairs inside the groups. And you could say I'm going to remove 3 groups of positive 2. So if I remove the 3 groups of positive 2, I have negative 6. And this is easy to do if they're doing this right here. Let's say that this is my 0 pairs, right? And I say I'm going to remove 3 groups of positive 2, and they just mark out these. And then at that point they have negative 6. Now this one says I'm going to remove 3 groups of negative 2. What I say instead of doing this is I'm going to do the opposite of 3 groups of 2, which would be 3 groups of negative 2. So it's the opposite of 3 groups of 2. And that's what I tell them. I'm doing the opposite of 3 groups of 2. And that's what I use. Opposite of 3 groups of negative 2 would be positive 6. So opposite of 3 groups of negative 2, because that negative's in the front, then I get positive 6. So you can do that. That's another way to do this. Now after they've done this, again, you're going to see a pattern, especially if you put it up like this. So when I had both positives, I had a positive. When I had a positive and a negative, I had a negative. I'm going ahead and multiplying. I've got a negative and a positive, but that's teaching the algorithm. And like I said, I want them to see the algorithm being developed. So do this several times this way. Let's just work a couple more out and look at those. So let's work 4 times -3 to -2 times 6 and 3 times -2. Okay, so let's just work these out. And what does that say? I'll turn my paper over here so we can see it. This one says I've got 4 groups of -3. That's exactly what that says. I got 4 groups, -3. So I'm gonna put -3 in each one of my groups. Four groups of -3. And my answer will be -12. It's red, it's negative, -12. Next one says I'm going to have the opposite of 2 groups of +6. So the opposite of 2 groups of +6 would be, let's look at that, 2 groups, bad circle there. The opposite of 2 groups of +6. So now I can go ahead and put my +6 here, and I'm going to say the opposite of. Now if I do the opposite of, what do? We just flip them over, right? So I'm going to build my 2 groups of +6. And I'm going to say it's the opposite of 2 groups of +6, which would be -6. The opposite of positive is negative. This is why it's so important to do those 0 pairs, guys. And then that becomes -12. Now this one says 3 groups of -2. 3 groups, -2 is -6. Like I said, oh well, let's do one more. Let's do a negative and a negative. So -2 times -4. So this says we're going to have 2 groups of -4. We'll start with that. So 2 groups of -4. So first group, second group, -4. Now I gotta look at it. This is the opposite of 2 groups of -4. So the opposite of -4 would be +4s. And after a while, the kids will be like, well, that's going to be +4. I'm not even going to have to build that -4. And then they're going to see that that's 8. And again, they see a negative and a negative, and that becomes the positive. They see a positive and a negative, and that becomes a negative. A negative and a positive becomes a negative. And then a positive and a negative is a negative. They see that by building it. And you don't throw out an algorithm and then they don't understand why that happens. This is really important for our students to build that. Okay, let's move on. Okay, so for division, we always talk about division as this is the total amount and this is the number of groups, right? Now, I have always told my students you can't have a negative group. It's just not possible to have a negative group. So at that point, we're going to say it's going to be the opposite of that. So we're going to go ahead and do the division and then determine if it's the opposite of because it's a negative group. So in this case, it's 12 divided by 4 into 4 groups. So we do that fair share. So we're going to do that fair share again. That group gets 3, that group gets 3, that group gets 3. This group gets 3, so how many is in each group? Well, in this case, it's +3. Now, I can't have a negative group again, so it's going to be the opposite of that 12. So the opposite of that 12 when they're divided into groups is what? Or you could say you're going to remove the groups of the positives. So, but in this case, I usually just say we're going to do the opposite of. We do the division and then we do the opposite of. So in this case, this is -3. Now, I have -12, which is what I have here now, and I'm going to divide it into 4 groups, which is what? -3 again. In this case, we're looking at -12, and I want the opposite of my groups. So now, the opposite of 4 groups would be +3. Again, we see positive and a positive gave me a positive. A positive and a negative gave me a negative. A negative and a positive gave me a negative. A negative and a negative gave me a positive. So I want them to start to see that, but I want them to build it first and talk about the opposite of. Now, so that's addition, subtraction, multiplication, and division with integers. So our next video that we're going to be putting out will be actually just writing an expression.